we have seen that many properties, they naturally hold good on lattices, so we need not do anything, they naturally hold good. But then if you look at this distributive property, it does not hold on every lattice. But if you can find a lattice on which this distributive property holds, then that is called as distributed lattice, and it is a special type of lattice. Okay, so one of the category. So see this. Now distributed lattice is one if it satisfies the distributive law. So what is the distributive law? Like this: A, R, B and C. So what is R and N? We have already seen it. It is least upper bound, it is greatest lower bound. So A or B. So see this, R is distributive over N, right? And here it is and is distributive over R. So if R becomes distributive over N and N becomes distributive over R, then such properties are called as distributive laws. Now if these distributive laws hold good on a lattice, then it is called as distributive lattice, right? So how to test whether two lattices are distributive, a given lattice is distributive or not? If they give any lattice and if they ask you whether it is distributive or not, you are supposed to check these two laws for every three elements present in the lattice. It is going to be a headache. In the sense, you have to do a lot of work, cumbersome. So how can you cut it short? So in order to check whether a lattice is distributive or not, we can go with a shortcut. There are actually two ways. One way is take every three elements and see whether these two properties are satisfied or not, but that is going to be very cumbersome. And the other way is identifying the sublattices and then doing some operations on them. So therefore, to find out whether a lattice is distributive or not, we have to understand what a sublattice is. Once we understand a sublattice concept, then we can again come back and I can analyze whether a lattice is distributive or not using that sublattice concept. So actually these two concepts are not related. Distributive is separate and sublattice is different, but then I use this concept in order to find out whether a lattice is distributive or not. That is the reason why we are looking at this sublattice here. Now see this, let capital L be a lattice. In general, lattice is represented like this. This is a general representation, like how poset is represented. Poset is represented like this, right? Similarly, a lattice is represented like this. So it just means that L is a set. It is set of all elements, and for every pair of elements there will be GLB, greatest lower bound and least upper bound. That is the meaning of this one. So these two operations are defined for every elements. Now let L be a lattice. Then we are trying to define the sublattice. A subset M of L, which means whatever set the base set is there, from that we are going to take a subset. Now the subset M of L is called the sublattice if M is a lattice. What does it mean? If you take the set M itself, for every two elements in M there should be the GLB and LUB. If this happens, right, then it is called a lattice. So first point is M has to be a lattice, and then the second point is for every pair of elements the GLB and LUB are same in both M and L. So I am not sure whether you understood this or not. With examples I'll try to understand. I'll try to explain this, and then we shall see again going back to distributed lattice. Okay, so don't get confused here. These concepts are bit tricky, but once you understand they will be very easy. So we know what is a poset, right? And if in a poset, if every two elements are going to have GLB and LUB, we call it as a lattice. And lattice in general is going to have many properties which will naturally hold good on a lattice, but if the special property, the distributive property, holds good on every three elements, if you take every three elements from L, and if distributive property holds good, then that is called as distributive lattice. But then given a lattice, if you have to check whether it is distributive or not, you have to take every three elements in the lattice and you have to see whether this distributive property is holding good or not. But it is going to be cumbersome. That is why we are defining something called as sublattice. Using the concept of sublattice, and if I apply some few other concepts, then I can find out whether a lattice is distributive or not. That is why from distributive lattice we are going towards sublattice. But distributive lattice and sublattices, they are not at all connected in any way. Now if L is a lattice, then if M is a subset of that lattice, So what do I mean by that? The base set, whatever this set A is there, you take a subset of this, which means if you have, let us say, 10 elements in the set L, then you take some of them, then that is called subset. Now if this subset is going to be a lattice, so that is the first point, right? So what does that mean? If you take every two elements in the subset, the LUB and GLB also should lie in the same subset, then M is called as lattice, right? So if M is lattice and moreover the GLB and LUB of every two elements in M are same as the GLB and LUB of those two elements in L, then that one is called as sublattice. So these two are different concepts. Okay, I hope you are not getting confused. So where did we come everything from? We have the sets concept, and then we have the Cartesian product concept, and then we have the relation concept. And if a relation is going to be reflexive, anti-symmetric and transitive, then we call such a relation as partially ordered set, and then we call the set and the relation together as the poset. And in this, if every two elements have GLB and LUB, then we are going to call it as lattice, and if the lattice satisfies this distributive law, it is called as distributive lattice. And then a lattice, you can take a subset of it and then you can find out whether it is a sublattice or not. These two are distinct. Now I am going to use the concept of sublattice to find out whether a lattice is distributive or not, but we'll see it after some few other concepts. For now, let's see some other concepts. Later we can go to the problems. For now, just remember these concepts. Later again when we come across the examples, I'll explain this. Okay, so don't worry about this. With a lot of examples, it will be clear. Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.